this session, we're going to go over the questions about the dependent and independent t-test. There are several questions that were asked about this, and it seems to be creating some issues because I know several people are picking the wrong t-test to run on this. So I've got the data open, the practice means data. And the first question that it asks on here is, do differences in pre and post-test scores exist for those classified as low SES? I don't think anybody's having any trouble picking out the low SES or doing anything like that. Doesn't appear to be what's the issue. It's picking the right one, but we're going to do this anyways. So we're going to make sure we pick only those that are low SES. Okay. Don't need that. So we filtered out. We've only got those that are low SES. What we want to know is if there's a difference between the pre-test and the post-test. This is a paired test. We're only looking for each one who's classified as low SES. So we're going to select Analyze, Compare Means, Paired Samples t-test. And what we want to do is highlight both of those and slide them over here to where they're in variable 1 and variable 2. I'm going to do that again. Make sure they're both highlighted. Hit that arrow and move them over. The options, there's not anything we really need to worry about with that. So you hit OK. Give it a few minutes. Now, we had 12 students who were classified as SES, or excuse me, low SES. Here's their average score on the pre-test, average score on the post-test. We're not doing anything with this right now, so we're not going to worry about that. What we wanted to know is whether or not there's a difference between the pre-test and post-test, and is a significant difference. The primary numbers that we're interested in is this right here. Because this number is not less than 0.05, that means that there is not a significant difference between the pre-test and post-test scores. If you subtract 68 from 75.1667, you get negative 7.1667. So you can see how much difference there is and whether or not there's a significant difference. In this case, there's not. So what I've seen a lot of people doing on the practice rooms they're sitting in is doing one sample test. You don't want to do that. And what I'm going to do is, at the same time, is I'm going to keep all these and paste them into here. And I'm also going to write this up, and I'll send this out, the answer key out, after I finish making this video, so that you can, when you write these up, you have a better idea of what this is supposed to look like. Okay, so I moved all those over. Problem with this thing is the table that you get back is so wide, I've got to turn this on landscape to make it fit. Now, the next question that they asked is, do differences in pre and post-test scores exist for males? So I'm going to throw this out because I'm done with that. Now I'm going to go back to my filter, and I want to know, for males, do differences exist? So I'm going to move that. I'm going to use gender. If gender equals male, all that switches. Now, I got a different set. So again, I'm going to analyze this. Fortunately, one of the things this does is, while you're working on something, it keeps track of everything that you do. That pre-test and post-test set is already set up. So all I have to do is hit OK. Now, I've got 12 males. I've got 12 male scores for the pre-test and the post-test. Here's the average score here, the average score here. This time, because this number is less than 0.05, there is a significant difference. Now before we saw a difference of about 7 points, now we're seeing a difference of 10 points. That's enough to say something significant occurred between these two. So I'm going to keep this and paste it in here. Keep this. Paste it in there. And again, we'll write that up so that you can see what, when you write a significant difference for a pair and a non-significant difference for a pair, what that looks like. The third question that it asked was about females. So all you have to do is switch from males to females and run it again. So I'm not going to go to the trouble of doing that in the interest of time because you only have 15 minutes to make one of these videos. The last question that it asked, though, is do differences exist between the pretest scores for those classified as low SES versus those that are classified as not classified as low SES? What we want to know is, before they ever did anything, did it matter whether or not they were low SES on their scores? Was there a difference beginning? And then asked about the post-test scores for the same group. Was there a difference between those who were classified low SES versus those not low SES on their post-test scores? Those are two independent groups. There's not a pair. We're not comparing a pre to a post. We're comparing two different groups on the same test. So the first thing that we have to do is reset that so we have all cases. Now, again, they had said they want to know, is there a difference on their pretest scores between low SES and those not low SES? So when we analyze, we want to compare the means. We want to use an independent samples t-test. What we want to look at, the test variables we want to look at are the pretest scores and the post-test scores, and we can run both at the same time. The grouping variable we're interested in is the low SES. To do this, we have to define what those groups are. One group is yes, one group is no. No options we need to look at. It's going to give us our descriptives. Now, we have 12 who are low SES, 10 who are not low SES. There is the average score for the low SES on the pretest and the average score for low SES for those who are not SES for the pretest. And then it has the post-test scores. Down here is the significant differences. This is Levine's test, and this is written in one of the examples that I gave you, is what's important, because we want to make sure that we are comparing similar groups, that those who are low SES have the same shape of distribution as those who are not SES. And this Levine's test for equality does that. As long as this number is greater than 0.05, we stay on this line. We can assume that the distributions are the same. Same thing here. We can assume the distributions are the same. If they're not, then we have to drop down to this line. So in this case, the distributions are considered to be pretty close to the same. Now, the t-test significance is this number. Because this number is not less than 0.05, then we can say that there is no significant difference between those two groups. And considering there's only 0.2 points difference between those two, that's probably entirely accurate. Same thing here. They're the same. They're statistically the same. Because this number is not less than 0.05 on the t-test, the two groups are statistically equal. And if you subtracted these two numbers, you get that. So again, I'm going to write this up so that you can see what it looks like. and I will post that in Blackboard so that it's available to you. That's the two types of tests that you can run. There are independent tests and there are dependent tests. A t-test is for only two groups. You can only compare two. If you get more than two groups, you have to use the ANOVA. The difference between, to know whether or not to use a dependent or independent, is whether or not you're comparing one group to itself, or if you're comparing just the males and you're comparing two tests. Or, and that's for the paired sample test. The other option you can do is compare two groups on one test. That is a independent test, and I'm going to rewrite that as well so that that's completely clear. So that's it.